second oldest engineering institute in India, has evolved during the last 158 years and has been given the status of an institute of national importance by the Government of India on March 2014 due to its excellence in education and research, and has since been known as the Indian Institute of Engineering, Science and Technology, Iiest, Shibpur. Cutting-edge research has been a high priority area of the institute, and keeping in mind the ever-increasing global energy demand and the need for a cleaner and smarter tomorrow, the Center of Excellence for Green Energy and Sensor Systems was established in 2009 in erstwhile Bengal Engineering and Science University, Shibpur. The center has since been functioning as a seat of multidisciplinary research and education and is honored to have some of the best people from across the globe to facilitate research and technology development on various components of green energy and sensor systems. The vision of the center is to enable India become one of the leading nations in the area of green energy and sensor systems. The mission is to develop indigenous capabilities in both these areas and undertake research leading to viable technology development and their utilization for societal benefit along with manpower development. Moreover, Department of Power, Government of West Bengal has identified this center as a center of excellence in renewable energy, and the center gained significant importance after the launch of the National Solar Mission in 2010, in which the solar power target was later ramped up to 100 GW by 2020 to accelerate solar deployment in the country. The mission of the center is very much in line with the Make in India initiative of the Government of India, and the research and development activities of the center not only focus on next generation future technologies but also provide a significant thrust to existing technologies and their utilization for societal benefits. A research and development wing on solar photovoltaics has been set up, and the center is privileged to have fundings from Ministry of New and Renewable Energy and Department of Science and Technology, Government of India, to carry out advanced research on all components of PV technology, including next generation solar cell technologies. A consortium of institutions has also been formed to set up a solar energy hub at Iiest, which is also a flagship project of DST. In a comparatively short time, Cegss has developed into a major national center for different components of PV technologies and sensors. A main component of PV technology is to establish the fabrication line of solar cells. State-of-the-art facilities have been created to develop industry-grade crystalline silicon cells having 16 to 17% efficiency, which starts with the saw damage removal and texturization of 6-inch square solar-grade silicon wafers. Subsequently, the wafers are loaded into the diffusion furnace for forming the PN junction. After removal of the phosphosilicate glass, the 6-inch square wafers are sliced into 3-inch square wafers for further processing. Edge isolation of the sliced wafers are then done by plasma etching using fluorine chemistry, and silicon nitride anti-reflection layer is deposited in a PECVD system involving silane and ammonia gases. Thereafter, screen printing of the conducting pastes are done to realize the back and front contacts in two separate printers, and the pastes are dried in two separate drying belt furnaces to avoid contamination before co-firing in a high temperature belt furnace. The finished solar cell is finally characterized with a sun simulator to obtain the current voltage characteristics. State-of-the-art facilities for fabricating thin film amorphous silicon solar cells having an initial efficiency of 9.5% have also been achieved, which mainly involves a 5-chamber plasma-enhanced chemical vapor deposition cluster tool with several gas lines of specialty gases to deposit the amorphous silicon layers. The transparent conducting oxide glass superstrate is loaded into the system, and the amorphous P, I and N layers are deposited sequentially in separate chambers to avoid contamination before being finally unloaded. The contacts from the solar cells are taken in a metallization system to obtain the final solar cell for measurement and analysis. to carry out routine and extensive characterization on various steps involved in solar cell fabrication and to gain a deep insight into each unit process. State-of-the-art characterization facilities have also been created to push the boundaries of existing technologies and pursue cutting-edge frontline research. Facilities include atomic force microscopy, UV visible spectrophotometer, thickness profiler, field emission scanning electron microscope, to name a few. Current research activities include novel light trapping schemes involving nanostructures, minimization of series resistance of solar cells, micromorph solar cells, 3D nanophotonic solar cells, flexible solar cells, interdigited back contact HIT solar cells, and organic inorganic solar cells including perovskites. For proper storage and distribution of generated power, it is important to translate the developed technology through actions which have a direct societal impact. Activities relating to photovoltaic systems and applications are carried out in the Photovoltaic Systems Laboratory named Robi Kutir and involve grid-tied solar photovoltaic systems, standalone solar photovoltaic systems, state-of-the-art inverter designs, and centralized solar lantern charging systems. The center has designed, developed and installed solar tree, solar boat and solar float, and already deployed solar auto rickshaw for the people of the state with active industry collaboration. Frontline research activities include vanadium redox flow batteries, MPPT charging of supercapacitors, design and development of FPGA-based grid-tied inverters, and smart microgrid systems. For proper utilization of solar energy, it is also essential to have a holistic view of solar radiation and various weather parameters associated with a particular location. Iiest, in collaboration with CVET MNRE, have installed SRRA and AMS for monitoring the local weather conditions. Further, sensors have become an integral part of our daily lives, and the significance of sensor technology is constantly growing. With a separate unit for sensors, Cegss is also involved in synthesis of various sensing materials, their characterization, prototyping, and development of market-ready sensing gadgets for various societal needs. LPG gas leak hunter, methanometer, manhole gas detector has already been developed by our research group for the safety of people working in hazardous environments. The center also aims to impart quality manpower training and is presently offering a postgraduate degree on renewable energy science and technology and doctoral program. With around 30 budding researchers pursuing their doctoral program, the center thrives to achieve global recognition, expand its scope for the use of other renewable energies, emphasize on development of cutting-edge technologies, closely collaborate with industries, and reduce the carbon footprint for a cleaner and smarter tomorrow for our future generations.